So section 2.4 is on solving multi-step inequalities, which you should be familiar with from chapter 1 when you were solving with multi-step equations. So your learning target is that you'll be able to solve multi-step inequalities. There isn't a core concept here because you've done so much work with solving multi-step equations. What you need to remember is that in solving, you use kind of like that reverse order of PEMDAS. So when we look at our first problem here, we have x over -2 plus 4 is greater than -1. And we're trying to get this x here by itself. In using the reverse order of PEMDAS, we're going to move this 4 first. So the opposite operation of plus 4 would be to subtract 4. So we're going to subtract 4 from both sides. So we have x over -2, our 4's here cancel, is greater than -1 minus 4 is -5. And then over here we have x over -2, or x divided by -2. So the opposite operation here would be to multiply both sides by that -2. And since we multiply by a negative, we need to flip that inequality symbol. So our -2's cancel, and we're left with x is less than -2 times -5 is +10. So this is our solution, and then we do still need to graph this. So I'm going to draw our number line here. And we have a point at 10, an open point because it's not equal to, and our inequality symbol is pointing to the left, so we are going to shade to the left. So here's our second answer for this problem. For the next one, we have 3c minus 2 is less than or equal to -11. So again, we're going to start by undoing the addition or subtraction first. So here we're going to add our 2 to both sides. So we have 3c, this cancels, bring down our inequality. -11 plus 2 gives us -9. Again, we're trying to get the c by itself. This is 3 multiplied by c, so the opposite operation is to divide here. So our 3's cancel, and we have c is less than or equal to -3. -9 divided by 3 is -3. And this time, notice we did not flip your inequality symbol because you're dividing by a positive. So even though you're dividing into a negative, you are dividing by a positive. So your inequality symbol stays the same. So now we need to draw our graph. I'm going to put my -3 here. This time we're using a closed point because it's equal to, and again, we're shading to the left. So here is our second answer for this problem. Example 2 is solving an inequality with variables on both sides. So when you have variables on both sides, you always want to start with your variable and move it to the left side because you want your final answer to have the variable on the left side. So first we have this +3x here. So we're going to start by subtracting the 3x on both sides. And I'm going to make sure that I'm writing it underneath my like terms, my common terms with the x. So 5x minus 3x is going to give us 2x. I'm going to bring down the -6, bring down my inequality symbol. My 3x's here cancel, and then finally bring down my 4. So now we're working on getting this 2x by itself, so we're going to add the 6 over. Bring down my 2x. My 6's cancel. Bring down my symbol, and here we have 4 plus 6, which gives us 10. And then finally, we have 2 times x. This is being multiplied. So my opposite operation here is to divide. So we're going to divide both sides by 2. So our final answer is x is greater than or equal to 5. And for this problem, we're just asked to solve. We don't need to include the graph here. Example 3 is looking at inequalities with special solutions. So you have inequalities with special solutions when your variable is eliminated in the solving process. So let's look at the first problem. We have 6t minus 4 is greater than 2 times the quantity 3t plus 5. So first we need to start by distributing this 2 to both of these terms inside my parentheses. So we're going to bring down the 6t minus 4 as well as the inequality symbol. Then we have 2 times 3t, which gives us 6t, and then 2 times 5, which is 10. So now we have variables on both sides of our inequality. We want to get the variable on the left side. So I'm going to take this 6t and subtract it from both sides. So this 6t cancels out, so I have negative 4 is greater than, and this 6t cancels out, so I bring down my 10. So now my variable has been eliminated. So I'm left with negative 4 is greater than 10. So now we have to think, is the number negative 4 greater than negative 10? And here it is not. This is not a true statement. So when we get a false statement like this, our answer is going to be no solution. Okay, the second problem, we have 2 times the quantity 2x minus 3 is less than or equal to 9 plus 4x. So again, we're going to start by distributing this 2 to what I have inside my parentheses. So 2 times 2x gives me 4x, and 2 times negative 3 gives us negative 6. So then we're going to copy down the rest of the problem. Again, we have variables on both sides. We want to move this variable to the left side. So we're going to start by subtracting the 4x on both sides. So these cancel. I'm going to bring down my negative 6, bring down my inequality symbol, bring down my 9, and these cancel. So my variable has canceled, and I'm left with negative 6 is less than or equal to 9. So now I want to look at this statement and determine if it's true or if it's false. Is negative 6 less than or equal to 9? Well, yeah, negative 6 is less than 9. So because this is a true statement, my answer is all real numbers. And you do want to write out this entire phrase, all real numbers.